All right, so now we're doing 2018 exam number 6. They start by giving the series ln of 1 plus x, and I'm going to write it out here, what they have, just so that we can see it written on the paper. So this will take me a second, but just hold on. It'll be worth it so that we can see it here together. All right, so that is for ln of x plus 1. On its interval of convergence, this series converges to ln of 1 plus, or I said x plus 1, 1 plus x, whatever. Let f be the function defined by, and here I'll write out f of x as well. All right, so this one is ln of 1 plus x, and then f of x is given by this. So there's two kind of transformations that are going on there. Everywhere there's an x, you would replace it with x over 3, and then you multiply the whole thing by x, because I think isn't that what they asked for in A? Yeah, A, write out the first 4 non-zero terms and then the general term for f. All right, so again, these are the two transformations that we have. Everywhere that there is an x in here, we're going to replace it with x over 3. So this first term would then be x over 3. And then you multiply it by an x. All right, so the next term would be minus. And I'm going to replace that x with x over 3. And then multiply it by an x. And then just keep on going here. So wherever there's an x, replace it with x over 3, multiply it by an x, and then one more. Now, I'm going to clean this up a little bit before I try to write out the general term, because this is the hardest part, really. But if you kind of like simplify this a little bit, it makes it a bit easier. This term would be x squared over 3. All right, and then here you would have x squared and then times another x. So that's going to be x cubed. And then I'm going to bring this 3 squared down to the denominator. So it would be 3 squared times 2. And I know 3 squared is 9 and then times 2 is 18, but it's actually easier to write the general format if you don't multiply all that together, because it's easier to notice the pattern if you leave it separated. All right, so this will be x to the 4th, and then I'm going to bring that 3 cubed down to the denominator and then times 3. And then here, this will be x to the 5th over 3 to the 4th times 4 plus ... plus. Now, when you have it written this way, it's a little bit easier to write the general form. It's still alternating. So you're still going to have this -1 to the n plus 1 there. Now, this is the first term, second term, third term, fourth term. So let's deal with the x's first. For this one, if n is 1, we have x to the power of n plus 1. And then same thing here. If this is the second term, 2 plus 1 is 3. And if this is the third term, 3 plus 1 is 4. So it's n plus 1. And then in the denominator, we have 3 to the nth. This is 3 to the first, 3 to the second, 3 to the third. So for the first term, it's 1, second term, it's 2, third term, it's 3. So 3 to the nth, and then times n. This would be times 1 if you want to put a 1 there. So 1, 2, 3, 4, it's times n, the nth term. So unfortunately with this problem, I don't know if you want to agree or disagree with this, you need this in order to get through the next parts of the problem. And if you couldn't get that general term, you're kind of out for the rest of this, which is really unfortunate, but you need that in order to do part B. All right, so that was part A. Part B, determine the interval of convergence for the Maclaurin series F. So that's this one. Show the work that leads to your answer. This is a lot of work that goes into this, just as a disclaimer beforehand, just as a heads up. You have to do, for your interval of convergence, you have to do the ratio test. If it comes out to less than 1, that's where the series converges. So we're going to do the ratio test, make that less than 1. That gives you the radius of convergence. And then you have to test the endpoints to see the interval of convergence. All right, so buckle up. Here we go. Here's your ratio test. It's limit as n goes to 0. I'm sorry, I'm losing my voice here. Limit as n goes to 0, and then you have this huge absolute value. Now what you do is you plug in n plus 1 to all these n's, and then it'll be over this statement. So it looks really awful at first, right? So everywhere there's an n, we're going to put an n plus 1. So that'll be n plus 2 for that. And then we'll have x to the n plus 2 over 3 to the n plus 1 times n plus 1. So again, everywhere that there was an n, we replaced it with n plus 1. And then that is over this statement itself. So I'm just going to copy that over. All right, so I do realize that looks horrible. Stuff is going to cancel in the next step. So limit as n goes to infinity. Now, when you divide by a fraction, you multiply by the reciprocal. So we're going to flip this over. So all this stuff is going to go up to the numerator. Also, this is an absolute value, so I'm not going to write these negative parts anymore. When you absolute value a negative, it's going to turn positive. So I'm going to kind of just leave those out in this next step. All right, so in the numerator, we're going to have x to the n plus 2 times 3 to the n times n. Again, this stuff in the denominator comes up to the numerator. And then it's over everything else. You kind of want to match them up. I'm going to write the x to the n plus 1 first. And then we'll have 3 to the n plus 1, and then times n plus 1. So already that's a lot less horrible than it just was. And now we're going to simplify this down. So limit as n goes to infinity. Let's see. We have x to the n plus 2 over x to the n plus 1. Well, all those x's are going to cancel except for 1. We'll just have an x in the numerator. Same thing's going to happen to the 3's, except the 3 to the n plus 1 is in the denominator. So we're going to have a 3 down there. And then these don't cancel. You're kind of just stuck with them. So you have an n in the numerator, an n plus 1 in the denominator. I'm going to go ahead and distribute the 3 through that. It'll be 3n plus 3. Only because that makes it a little simpler when we go to do limit as n goes to infinity. This is n to the first. This is n to the first. So whenever it's a tie like that, you use the coefficients. And so we get absolute value of x over 3. So when we're evaluating that limit to infinity, these powers are the same. So we use what's in front of them. And again, for your ratio test, this is going to converge where it's less than 1. I realize that is a lot. So we set up the ratio. We did the reciprocal here and we kind of lined them up. We simplified it down. Then we did the limit less than 1. So if you multiply this 3 over, you get absolute value of x less than 3. And so your radius of convergence is 3. And I always kind of like a picture for this. We're centered around 0 and the radius is 3. So 3 units in each direction. Not done. That's the radius of convergence is 3. It means that this is 3 units and this is 3 units. The interval of convergence is going to be from -3 to +3, but you need to check if you're going to include them or not. So we're going to check each of the endpoints. So I'm going to let x equal -3, and we're going to just see what happens. Our series will be sum from 1 to infinity. And again, we're going to use this part that we got in part A. If you didn't get this in part A, you were really kind of sunk for the rest of this question, which is really a bummer. Because if this was wrong, then like you're using it for everything else here. You're using it for this ratio and it's the series that you're working with. All right, so we're going to plug in -3 for x. So this is going to be -1 to the n plus 1. And then for x, we'll have -3 to the n plus 1. And then over 3 to the n times n. All right, so this is negative and this is also negative. I'm going to rewrite this so that I'm taking the negative out. So here's that first part. I'm going to rewrite this as -1 to the n plus 1 and then +3 to the n plus 1. I just kind of separated this part. Instead of a -3, I wrote it as a -1 times 3. Algebraically, it means the same thing. But what happens there is you can think of these as canceling out. If you add the exponents, you get 2n plus 2, which is always going to be an even number. But again, you can think of it just as the negatives canceling. And then also these 3's are going to simplify. So I have 3 to the n plus 1 over 3 to the n. That would just be 3, and then we have over n. Phew, okay. I got that simplified down. It's a bunch of like canceling things out there. You have to decide if this converges or diverges. This is n to the first, and so it is going to diverge. So it diverges because it's a p series and p is 1. P has to be greater than 1 in order for it to converge. So when we let x equals -3, this does not work. It diverges. And then I have to let x equal +3. So I'm going to set this up again. Our series is from 1 to infinity. We have -1 to the n plus 1. This time it's just 3 to the n plus 1. And again, I'm using this part that I had back here in part A. It's the same thing as here. It's the same thing as there. I'm just plugging in 3. So this time I can't get the negatives to cancel. This is going to be an alternating series, which, by foreshadowing, we're going to do the alternating series test. These 3's still cancel. We'll just have 3 and then over n. So your alternating series test, there's 2 things that you check. It's limit as n goes to infinity of the part that's not the alternating part. Like you can leave that -1 out of there. That has to go to 0, which it does. As n goes to infinity, that's going to go to 0. And if you plug in n plus 1, that has to be smaller than, in this case, 3 over n. And that's also true. This is the bigger denominator, so it's going to be the smaller fraction. So this converges by the alternating series test. So once again, we did our ratio test to get r. That's our radius of convergence. We checked the 2 endpoints. This one didn't work, but this one did. So our interval of convergence is -3 to 3. This gets a parenthesis, this gets a bracket. That's a lot, but I'm glad we went over that because that reviewed like the majority of the information about infinite series because it was like all in there. All right, part C is not as long. If you're like, oh my gosh, how much is left to this question? That was the bulk of this question. And actually, you don't need this part for part C. So actually, we can get part C without that. Part C says, let P4 of x be the 4th degree Taylor polynomial about 0. Use the alternating series error bound to find an upper bound for, and then they give you absolute value P sub 4 of 2 minus f of 2. All you really need to remember for this, let me write this down here. We're plugging in 2 for this. All you really need to remember for the alternating series error bound is that you go to the next degree. It's n plus 1. So if this is a 4th degree polynomial, and sorry, I'm having to toggle back and forth between the screens to be able to see what I'm writing here. If this is a 4th degree polynomial, we want to use the term that has the 5th power. So going back up here, here is our term that has the 5th power. And it's negative, but we're going to absolute value it. I don't have enough space to show this all in one screen. I'm going to have to slide this down. But this is our term that has the 5th power. And we're going to plug in 2. So it's going to be -2 to the 5th over 3 to the 4th times 4. And that equals, and basically you just have to get rid of the negative. When you absolute value it, it's going to be positive. So equals 2 to the 5th over 3 to the 4th times 4. So for that last one, all you have to do is remember if this is to the 4th power, it's going to be less than or equal to the next term. You want the n plus 1. So if that was to the 4th power, you just pull out the term that has the 5th power, and they were saying to plug in 2 for that. All right, so points for this question. For part A, writing out these first 4 terms was a point. Writing out the general term was a point. So that was worth 2. For part B, setting up the ratio was worth a point. So if you set up this, you would get a point. Once you evaluate the limit, so when you get here, that's a point, this absolute value x over 3. And then getting that your radius of conversion was, or radius of convergence was 3. You get a point for that. You get a point for checking the endpoints. And then it says on the key, it's a point for your answer with the analysis. So I would assume that this analysis goes with that third point. And then the last one, you get a point for knowing to use the 5th term, and then you get a point for the answer, which that's almost like one and the same there. So that's, I mean, if you get 1 point, you're going to get the other one.